In this video, I will discuss some JEE Main PYQs from the topic motion in a straight line. These questions are based on equations of motion. The three equations of motion are V equal to U plus AT. Second equation of motion is the displacement S equal to U T plus half A T square. The third equation of motion is final velocity square equal to U square plus 2AS. These three equations of motion are valid in the situation where acceleration is uniform and constant. Uniform means the acceleration is not changing from point to point in space, and constant means the acceleration is not changing with time. That means the acceleration will be a real number. I will discuss JEE Main PYQs that have appeared in the years 2021 and 2022. I will discuss some 5 questions. This is the first one. The ball is thrown up vertically with a certain velocity so that it reaches a maximum height h. Find the ratio of the times in which it is at a height h by 3 while going up and coming down respectively. You can pause and attempt this question. So the ball is thrown up vertically, reaches a maximum height and comes down. So thrown at the initial velocity u, suggests that it reaches a height of h. So h by 3 is somewhere here. So at h by 3, it is at 2 times. One when it's going up, say t1, and the second time when it's coming down. T1 is the time taken to go from here to here. T2 is the time taken to go from here to up and then come down here. So at 2 instances, it is at the same height h by 3. So this height h can be related to this u using this relation v square equal to u square plus 2as. Let me take the upward direction as positive. So between these 2 points, v is 0, u is this u, acceleration is minus g because earth is pulling it down, upward direction is positive, and s between these 2 points is h. From this the initial velocity u is square root of 2gh. Between these 2 points, I can write is equal to ut plus half a t square. Between these 2 points, the displacement is h by 3. Acceleration is minus g. Upward direction is positive. This is a quadratic equation. So this will have 2 values of t which will satisfy this one. One value of the time will correspond to t1. It's a displacement h by 3 when it's going up. Another value of time t2 will correspond to the time when it's coming down and reaches the same displacement h by 3. So quadratic equation solutions are minus b plus or minus square root of b square minus 4ac by 2a. So before that, let me rewrite this thing in a convenient form. So half g t square minus ut plus h by 3 equal to 0. Now the solutions are minus b plus or minus square root of b square minus 4 AC. So 4 and a half will give me 2, and then here 1/3 is there. So 2 by 3. 4 into this, So 4 by 2 is 2, and then 2 by 3, and then GH divided by 2A, which is G. What I need is ratio of times T1 by T2. Denominator is same, they will cancel. So I can get T1 by T2. T1 is the lesser time, so I have to put the minus sign, and U is square root of 2GH. So here root 2GH is there, here 2GH is there. So I can cancel root 2GH. So it will become 1 minus square root of 1 minus 2GH will go. So 1/3 divided by 1 plus square root of 1 plus 1 by 3. T1 by T2 is the ratio of these numerators with the minus sign for T1 and plus sign for T2. Denominator is same 2A, that will cancel. And this is 2/3. So this will become root 3 minus root 2 divided by root 3 plus root 2. Same thing, only thing difference is the plus and minus here. Matches is option 2. 2 is the correct answer. So this is what I explained here. The ball is thrown up with the velocity u, reaches maximum height h. At h by 3 will be 2 times, one while going up, another while coming down. So to get the relation between this u and this h, I'll use this equation. And v is 0, u is u square, and then 2as. G, a is minus g because upward direction is positive. So from this I'll get u equal to square root of 2gh. And for this displacement, I'll use s equal to ut plus half at square. And from between this and this, the displacement is h by 3. And also between this and this point, the displacement h by 3. So it's a quadratic equation. We'll have two values corresponding to the two times here. So solving this quadratic equation, get this one. So t1 is a initial lower time, t2 is a later time. So t1 I will take the minus sign and t2 with the plus sign. So simplifying, I'll get this one. This is the next question. The NCC parade is going at a uniform speed of 9 kilometers per hour under a mango tree on which a monkey is sitting at a height of 19.6 meter. At any particular instant, the monkey drops a mango. A cadet will receive the mango whose distance from the tree at the time of drop is given g equal to 9.8 meter per second square. You can pause and this question. So this is a tree, and the carrot is moving like this. So from a height of 19.6 meter, the mango is getting dropped. So this height is 19.6 meter. So it will take some time to come from here to here. Within that time, some carrot here, from here to move up to this much. So to find this distance, straightforward question. Find the time taken for the mango to drop from here to here. U is 0, S is known. So S equal to ut plus half a t square. Okay, I'll take this as origin and the downward direction as positive. So displacement is 19.6 plus 19.6, u is 0 half g and then t square. So this is 9.8. So this will go 2 times. G will cancel this and give 2. So from this, t is 2 seconds. So the speed of this carrot is known, 9 kilometers per hour. So the distance d is speed of the carrot into the time, but the speed of the carrot is given in kilometers per hour. So converting the meters, multiplied by 1000 and per second divided by 3600. Per hour it is that much. So for 1 second to be less by a factor of 1 by 3600 into the time 2. 9 2s are 18. 92 is 18. So this will go 2 times here. So the answer is 5 meters, SI units. So option 1. What is the correct answer? So mango is dropped from a tree which is at a height of 19.6 meter. So it will take some time to come here. So that you can find from S equal to ut plus half a t square. U is 0. So from this time is 2 seconds, the time for the mango to come from here to here. So within this time, a carrot here would have moved this much distance. That will be the speed 9 in kilometers per hour to convert in SI units, kilometers to meter 1000, and hour to second 2600. Into the time 2 seconds, that will give me 5 meters. So the carrot who is a distance of 5 meter at the time the mango is getting dropped will catch this mango. To the next question. The small toy starts moving from the position of rest under a constant acceleration. If it travels a distance of 10 meters in t seconds, the distance traveled by the toy in the next t seconds will be. So the toy is moving from rest, so u is 0, acceleration is constant. So in t seconds, so here the time is t, the distance moved is 10 meters. In the next t seconds, say 2t here, the distance moved will be something else that we have to find out. S equal to ut plus half a t square, u is 0, so just half e into t square, and this is given as 10 meters. We call it S1. So 10 equal to half e t square. And the second displacement from here to here, S2 equal to u is 0 plus half e, and then time is 2t between these 2 points. 2t square. So that is half a t square into 4 times. So the distance traveled in the next t seconds, there is this distance d. This s2 minus s1. S1 is the distance traveled in the first 2t seconds, that's from here to here, and S1 is the distance traveled in the t seconds from here to here. So this distance minus this distance will give me this distance d. So that will be 3 times half a t square. This half a t square, that's, and half a t square is 10. Option 3 is the correct answer. Three is the correct answer. So tau is starting from this, so u is 0. So is equal to ut plus half a t square, becomes just half a t square. First t seconds is 10 meters, half a t square, and then in 2t seconds, the distance traveled will be half a t2 square. Dividing these two, I'll get 4. So st2 is 40, and s first, this one is 10. So the distance traveled in the next t seconds is 30 meters. First t seconds traveling distance of 10 meters, and from 0 to 2t, it's traveling a distance of 40 meters. So in the second t, the distance traveled is 40 minus 10, which is 30. This is the next question. The velocity displacement graph describing the motion of a bicycle is shown in the figure. So velocity versus x is shown like this. Acceleration displacement graph of the bicycle of motion is best described by. So a versus x. So what is given is velocity as some function of x. To get the acceleration, differentiate this in both the sides with respect to time. So you get acceleration as d by dt of this one, that can be written as df by dx into dx by dt. This chain rule of differentiation. d by dt is this one. This one, d by dt of this one is d by dx of this one into dx by dt. Dx by dt is nothing but velocity. So velocity into df by dx. So this graph, velocity is a function of x, that's given. So from this, df by dx of this part is slope of this line, which is 40 by 200, and this part the slope is 0 because it's horizontal line. It's not climbing up. This climbing up with a rate of 40 by 200 SI units. So 0 to 200 meters, this is the slope. So this acceleration will be, this slope is 40 by 200 into velocity as a function of x for 0 to 200 meters, the first part. And for the second part, it is 0. So second part it is 0. So these two options can be ruled out. This is not true. This is not true. And for the first part, the answer is velocity into the, this is 1 by 5. So it's V by 5. So V is 10, 10 by 5 is 2. And it should be a straight line because this thing is a straight line. So this also is straight line. This is just a number. 50 by 5 is 10. So 4 is the correct option. E is also not correct. 4 is the correct option. Velocity as a function of x is given. This one. So from this I have to find acceleration as a function of x, the 4 options, a versus x. So to get the acceleration, differentiate this one with respect to time. So it doesn't give me a. And to differentiate with respect to time, this I'll differentiate with respect to x, and then dx by dt, chain rule. And df by dx is slope of the curve f versus x, which is the slope of this v versus x curve. So in the first part, it is 40 by 200, 0 to 200 meters. In the second part, from 200 to 400 meters. So the first part, the acceleration is 40 by 200, that's 1 by 5 into v, so v by 5. Second part, the acceleration is 0. So acceleration 0 in the second part means these two options are eliminated, 2 and 3 are not valid, and this one and this one, and it should be a straight line in the first part. So option 4 is the correct answer. This is the next question. A scooter accelerates from rest for time t1 at constant rate a1 and then retards at constant rate a2 for time t2 and comes to rest. The correct value of t1 by t2 will be. So velocity time graph of this one. It's starting from rest and it reaches a, okay, it accelerates for a time t1. Will reach some value, say v. And after it retards, and this time is t2 for t2. So that means from here to here it's t2. So this time will be t1 plus t2. It's important to understand this one. The scooter is starting from rest for time t1 at a constant rate a1 and then retards at a constant rate for time t2. So from here to here it is t2. This interval is t2. Okay, so this velocity here I can find out by using v equal to u plus at. V equal to u0 because starting from rest plus e. For the first part, the acceleration is a1. Second part, the acceleration retardation is a2. So a1 t1. For the second part of motion, initial velocity is this one, v equal to u plus a. The final v is 0. So v equal to u a1 t and acceleration is retardation minus a2 into t2 and the final velocity here is 0. This is v equal to u plus a between these 2 points. Initial velocity is a1 t, final velocity is 0 and the acceleration is minus a2 because a2 is a retardation value. So from this t1 by t2, this is t1. It's acceleration for time t1. So t1 by t2 is a2 by a1. Option 3. 3 is the correct answer. The scooter is starting from rest and accelerates the rate of v1 for a time t1. So the final velocity v equal to u plus 8, u is 0. So it's a1 t1. And for the second part, the final velocity is 0. Initial velocity this final velocity for the first part, this is a1 t1. And then plus at, acceleration is minus a2. And then time is time interval t2. From this I'll get t1 by t2 as a2 by a1.